During this lesson, we're going to review just very briefly what you should have come away from with the activity that you did as an introduction to this unit. And then we're going to talk specifically about what does the derivative mean out in the business world, because calculus is heavily applicable when you're looking at business situations. So from the activity that you did to open this unit, we learned that the derivative of a constant is 0. And so, for example, if I have f of x equals 7, remember that we saw that that was a horizontal line, and the slope of a horizontal line is always 0. So the derivative of a constant is 0. The next thing we learned was the basic foundation of the derivative, and that is when you have a power. So we saw that to find the derivative of x to the n, we would bring the n down front, and then we would decrease the power by 1. So for example, if you have something like x to the 5th, the derivative of that is equal to bringing the power down front, which would be the 5, and then decreasing the power by 1, so that becomes 4. Now remember that these are all rules that have been developed as shortcuts and truly discovered in that way of just trial and error. The alternative is to do the 4-step method for finding the formal derivative, that f of x plus h minus f of x all over h, the limit as h goes to 0, should give you the same exact answer. All right. Now when we put a number in front, we simply have to multiply whatever coefficient was in front of our function and multiply that times the power and decrease the power by 1. Okay, so here we would just have a times n, or a times g prime of x is really all that is take the derivative of your function, but then multiply it by what's out in front. Okay. So for example, if we take the same function we just had, but we put a 3 in front of it, then the derivative of that is simply 3 times the derivative of x to the 5th, which is 15x to the 4th. And then the last thing that we learned is that the sum of the derivatives, or the derivative of things that are added or subtracted together, is simply that you add up, or you do the sum or difference of each derivative. So if you have a function where you have more than one piece, let me throw a minus in there, to take the derivative of that, you simply take the derivative of each piece. So the derivative of x to the 5th is 5x to the 4th. The derivative of 4x squared is 8x. The derivative of 7x is 7. And the derivative of a constant is 0. And so we wouldn't need that 0. So our final answer would be what I've underlined there. So those are the things that you should have pulled from your activity that you did as the chapter opener. And now let's talk about what that means in the business world. There are lots of different functions that are in the business world, but the 3 main ones are cost, revenue, and profit. And then the other key word is this word right here, and that is marginal. And the understanding of the word marginal is really important. So we're going to stress that in just a minute. So first let's talk about the cost function. The cost function generally is designated as c of x. And this stands for how much it cost to make a total number of items. So if, for example, my cost function is 3x squared plus 10, and I want to know how much it cost to make 10 items. It could be 10 bicycles, 10 whatever. Then we're simply going to plug 10 into 3x squared plus 10, and we're going to know our total cost. So this is our total cost. And so we do 3 times 10 squared plus 10, which would be 310. Okay. Again, that is not per item, that is the total cost. If I wanted to know on average what it cost me per item, I could then divide by 10 and find that it's about $31 an item. But remember that that would be an average cost, because it's normally more expensive for a company to make the very first item than it is to make the 10th item, because you have all the startup cost of getting your equipment. So to just make one item can be pretty pricey. Now let's talk about what marginal cost is. Marginal cost is the derivative of cost. Well, if we think about what derivative means rate of change. And so what marginal means, or marginal cost means, is how much will the cost go up or down? How much will the cost change if I change the number of items that I want to make? So if I'm currently making 10 items, but I think I want to make 11, so I want to make one more, will my cost for that 11th item be huge, or will it be small? And it depends on the company. If my warehouse, let's say I'm building cars, and my warehouse can only build 10 cars, I am maxing everybody out. I've got people working full 40-hour weeks, I'm using my factory 24/7, all of that. Then for me to make one more car is going to be huge, because I need another whole set of employees. I have to train them. I have to buy a new or rent a new warehouse. I have to get new equipment. So making that 11th car is not going to be productive for me. But if my people aren't working hard enough, if my factory is not being used around the clock, making one more bicycle might be a very low cost, because I already have everything I need to do that. I just need to tell the people to make 11 instead of 10. So businesses look at this all the time on, should we make one more, and will, whether or not it eventually will turn a profit. So the key is that when you find the marginal cost, it is the cost to make one more. So first, let's take the derivative of the cost function. So the derivative of 3x squared plus 10, the derivative of 3x squared is 6x. The derivative of 10 is 0. So our marginal cost function is 6x. Now, if I plug 10 into that cost function, that is going to find me the cost of making number 11. Not the total cost for all 11. It is the rate of change. How does the cost change when we change by 1 unit? So if I plug in 10, that's going to tell me how much I should expect it to cost me to make number 11. If I plug in 20, it's going to tell me how much is it going to cost me to make number 21. Now remember back over here on the cost that we determined that for 10 items it cost us $310, which was an average of $31 per item. And again, I just got that by dividing 310 by 10. So let's see what the marginal cost is to make number 11. We plug in 10, and this says it's going to cost us $60 to make the 11th item. Now, if we are only averaging that for the first 10, it's only taking us $31 an item, then that tells us that we're probably maxing out our staff, and the fact that it's going to take $60 to make the next item, or you could look at that as 60,000 or whatever we're talking about, says that maybe I probably don't want to do that because I can't sell the item. I can't sell the 11th bicycle for $50 more than I sell the 10th bicycle. I mean, it's the same bike. So I can't make more money. So the fact that it's going to cost me more means it's going to take from my profits. So companies will look at that. So that is marginal cost, or cost and marginal cost. And so again, the word marginal, we'll say this over and over, but the word marginal is the derivative. It's the rate of change. So no matter what we're talking about, if we do the marginal of that, it's how much will it change if we do one more. So now let's talk about revenue. Revenue is the amount of money that you will get from your sales. Okay, so you put 10 bikes out there and you sell them all, and you sold them each for $50. So your revenue is $500. That's how much money you are bringing in to the company. So if we have something like R of X, which is our revenue based on selling X items, and this is for the total number of items. So it's not telling us how much we're selling each item for, but it is telling us how much we'll bring in. What if we sold 10 items? Then we would do 10 cubed plus 10, which is 1010. So if we sold 10 items, we would bring in $1,010. Again, if we wanted to have an idea of how much we're selling each bike for, so let's say that I didn't have a set price, or if I did have a set price, then this will be exact. But what if people made bargains on these things? What if they talked the seller down? But on average, if we divide by 10, that says that we were charging about an average of $101 per item. Okay, so we sold 10 bikes. We charged about $101 a piece. We might have charged exactly $101 for all of them, or somebody might have paid more and somebody might have paid less. It's costing us about $31 an item to make the product. So the cost is $31 an item. The revenue is about $101 an item, or a total of $1,010. So based on the discussion we had about marginal cost, marginal revenue is going to tell us how much money we will bring in if we sell one more. So what's going to be our growth in our revenue if I say, you know what, instead of selling 10, I want to sell 11. What will that do? Well, first we take the derivative of x cubed plus 10, and the derivative of x cubed is 3x squared. The derivative of 10 is 0. And now remember, to find out about the 11th item, we plug in 10. So this is the money coming in for just the 11th item. And so we're going to do 3 times 10 squared, and we actually get 300. So because perhaps, why might this happen? Think about the Wii system and how much people were willing to pay for that Wii. So I only made 10 Wiis and I sold all 10. And the word got out that everybody has to have a Wii. So you make one more. Well, the demand is so high that people are willing to pay $300 instead of the $100 that the other people paid on average. Well, now you take a look. So this is the $300 if you sell one more. Now let's do a little comparison over here. So I highlighted in green what we were currently doing, and I highlighted in purple what we're thinking about doing. So what we're doing right now is we're spending about $31 to make our item, and we're selling it for 101. So we're making about, and we're going to talk about profit in a minute, but we can go ahead and talk about it now. We're making about $70 in profit. But apparently everybody wants what we've got. And so we can make one more, which will cost us more. It's going to cost us 60 bucks, but because the demand is so high, we're going to be able to sell that for around 300. And so a good business person would say, looks good to me, and let's make that one more item. Now what companies have to worry about is not getting greedy. And this happened with things like Cabbage Patch Kids. It really happened with the Beanie Babies. The Beanie Babies were selling like wildfire. The prices were outrageous. So they were making them for $6 a piece and selling them for $30 a piece if we use these same type of numbers. So what the Beanie Baby company said is, let's make more. And they kept coming out with more and more and more choices. And they started to saturate the market. And eventually what happened is that the Beanie Baby market just fizzled. People just started saying, you know what, I've had enough of this. For a year and a half I've been buying these Beanie Babies. I've spent thousands of dollars on them. And the market went kind of belly up. Now they didn't go out of business or anything, but what happened was they oversaturated because they got greedy. And they kept saying, well, heck, we'll make one more because then everybody will pay $300 for it. And that's what causes things like the Beanie Baby market and the Cabbage Patch Kids market and all those different types of things to kind of fizzle out. The Wii company lasted a lot longer than most companies. And the reason that is they did not saturate the market. They actually made it through several Christmases, and usually fad gifts only last one Christmas. But they made it through several because they only produced a low number. They produced those 10 Wii systems, but they refused to produce the 11th. And so people still wanted it. For 3 years, people still didn't have the Wii they wanted. And so the Wii system, up until this past Christmas, in 2011, so 2010 Christmas was the first Christmas where there were Wii systems left on the shelves. And so what that indicates is they've now saturated the market, and their people now have to look at, okay, everybody has the Wii, so now what we need to do is start creating the games and the things like that that will keep the money coming in. So they were very smart in that they did not saturate the market at a high rate. So now let's take a look at profit. Profit has to do with how much money the owner gets to stick in their pocket at the end of the day. So cost is how much you're spending on stuff. Revenue is how much money you're bringing in, but that revenue has to pay all the bills. All right, so we have to pay all the expenses, and then whatever's left becomes our profit. So our profit statement is when you take all the money you brought in, which is the revenue, and you subtract from it the cost. Okay? And so if we look at our two statements here, our revenue was x cubed plus 10, and this is why back in algebra you had to learn the concept of combining functions. And the cost function was 3x squared plus 10. And so if we clean this up, we get x cubed minus 3x squared, and the 10 minus 10 are gone. So if I want to know the profit that I'm going to make for 10 items, I can plug 10 into each of these. and I get 1,000 minus 300, or 700. Now, we kind of already knew that because we had a cost of $310, a revenue of $1,010, and if we just subtract those, we get 7. So sometimes it's easier to just find your revenue, find your cost, and subtract them. But if I needed a cost function, then we need that right there. So we technically already know the answer to the marginal profit as well, because the marginal profit is simply the marginal revenue. So the marginal profit is equal to the marginal revenue minus the marginal cost. Well, our marginal revenue for our example was 300. The marginal cost was 60, and so we had, I believe, 240. Now the other option is you can take the derivative of the profit. Okay, so we can do it either way. So for the marginal revenue, our marginal revenue was 3x squared. Our marginal cost was 6x. And we can either get that from going up above and pulling it, or we can take the derivative of what I just highlighted in yellow, the x cubed minus 3x squared. So you have two ways that you can find marginal profit. So now, if I plug in a 10, what this is going to tell me is the amount of profit if I sell and make, or make and sell, I guess I went in the wrong order, the 11th item. Okay, and so we plug in 10, and you'll see the numbers from up above, and we subtract, and we get $240. So if you're happy with $240 extra profit for the work of making one more item, then it would benefit you to make that. Back over here, remember to find the average, we would divide by 10. So on average, you're making $70 per item profit over here. So $70 profit versus $240 to make that one more is probably a pretty good deal. So again, just to review, that when you hear the word marginal, you should think of it meaning the change for one more. So if you're talking about marginal cost, the cost for one more. Marginal revenue, the revenue for one more. Marginal profit, the profit for one more. And so whatever number you plug in, you're saying, I'm already making that number. I'm already making 10. What's going to do if I make number 11? You can also look at the graphs of these and see what's going to happen as your numbers grow. For example, if we very quickly just look at the graph of the cost, that's a parabola that looks something like that. And so if these are all the cost values, look at what's going to happen to the cost as you make more and more items. So this is the number of items, and this is the cost. So as the number of items grows, the cost is growing. And so you have to kind of watch that. And so if you look at the slope, right here is where we would expect that we make no money, no extra money at that very one point, but or that we bottom out, but then our cost continues to grow. So whatever this point is a point at where you want to consider you might be most profitable in some cases, because here our cost is going down and per item, and then it starts going up, and it goes up without bound. So remember to continue to look at the graphs and make the connection that when you're looking at the graph itself, the cost function, each point on the graph is going to give you the total cost. So that blue point right there is going to tell you how much the total cost was for 10 items. But if you look at the graph of the marginal, or actually even if we just hover back over here, if you look at the slope of the tangent line at that point, it's going to tell you whether the cost is going to increase or decrease. So at the point that I marked, it's going to increase the cost. Over here on the left, it's going to decrease the cost, and right here the cost is going to be pretty consistent. It's not going to change. There's still a cost involved, but it's not going to increase that much. So make sure to always connect to the graph and ask, what does it mean? What does it mean in terms of what you're applying it to? So that will just help you start to make connections with the business applications. And next we'll be looking at the actual how to find the derivatives using all the different shortcuts.